Tell me what is string instruction? String instruction. It's coming so big. Yesterday I told you about string instruction. What is string instruction? What is string instruction? What is special with the string instruction? Tell me.
It reduces the number of code that is required for execution. Instead of like having 6 lines of code, you can just make it 1 line of code.
Exactly.
But the conditions are that the SI pointer should be there for the
Yes. Good, good, good. Right? I'm just trying to recall yesterday's topic. See, instead of using code, this much code, okay, to transfer data from one block to another block, we use just two lines of codes. This does the same thing what it is doing, right? But mainly what you have to do that, you have to load the source in SI compulsory, destination in DI, this is compulsory, and also this count has to be stored in the CX register. Okay, just a repeat instruction along with MOVESB. What this instruction does, this one instruction copies entire block of data from one block to the another block. You need not write this individual code at all. Okay, this is the function of MOVESB. What is MOVESW? It transfers the word, that's all. It transfers the word. In such case, your DI and SI will be incremented by 2, because every time word is transferred. In the memory location, one word is stored in the 2 location. Every time your DI and SI will be incremented by 2, provided your direction flag is equal to 0. Suppose your direction flag is 1, is it going to increment? No, it is going to decrement. That's why we have made here your direction flag to be equal to 0 here, because here we need your SI and DI to be incremented. Okay, now this is one instruction. Okay, you can see 6 lines of code to 2 lines. There's one more instruction called LODS. What is this LODS? So LODS is an instruction which loads the data, okay, from the address pointed by SI register. Okay, it loads the data pointed by SI register to AL register, right? Okay, to AL register. Now what happens here? See here, LODSB, it will copy the data, listen carefully, it will copy the data from a memory location pointed by SI register to the accumulator. So what is accumulator in microprocessor? Your AX register. The AX register in the microprocessor is called as an accumulator. Okay, there is a separate name given to that, it's called as accumulator. Okay, it can be used accumulating data. That's why this LODS will load the data from the memory which is pointed by SI right? Of course, the data is in the DS register, it will load it to the AL register. If it is 8-bit, it will be loaded to AL register. Okay. Similarly, see, load SB, it will load the data into AL register. Load SW will load into AX register. Load ST will be loading into the EAX register because it is double word. Okay. Now, once again, what is the difference between move instruction and this? What is the difference between move instruction and this? Right? If I just say data is loaded from the memory pointed by SI register to the AL register, then there is no difference between a move instruction and load S. When do we use load S? Whenever you are going to load a consecutive data to the AL register and do something in that, then you are going to use the string instruction. Have you understood? Right? As per the understanding of this load S instruction, what it says, it will just load the data from the memory pointed by SI register to AL register. You can very well do by using an instruction load effective address, okay? Load effective address SI, array. Then I can do move AL, comma SI. What this does, tell me? What these two instruction does? It does the same thing, right? It will actually move a data, the first element, into the array, in the AL register. Have understood this? Okay. Now you listen carefully. Why I have to use load SB? What load SB does? Load SB also does the same thing. Suppose if I execute an instruction load SB, okay, and similarly I will have this move, this one, load effective address. I have to keep this the offset address in the SI register. So I will use this. Now tell me, what is the difference between this and this? This also loads the data into AL register. What is the difference between this? Hmm?
I cannot think of anything else apart from that.
If I just write this statement, there is no difference, of course. Right? Now, suppose you continue this with incrementing SI, okay, and try to take the next data, okay. So what I should do, I should decrement CX. If I put something into move CX, comma, some count 32H. See here, increment SI. Now jump on no 0. Listen carefully. Jump on no 0, up. So what this does, tell me? What this code snippet does? What this code snippet does? This much. Tell me what this code snippet does.
Move the first data at SI equal to 0, SI the offset address into AL, and then keep incrementing and moving each and every bit of the data.
Wrong. Then look at the program. See what it is doing. Don't be in a hurry in giving answer. Just think. Look, see what it is doing. What this is doing, now tell me. What these statements are doing, I think at this point of view, you must be able to know what this code snippet is doing, what I have written here. Come on, somebody tell me. Come on, don't worry. See, try to tell something. Half correct. Right, but not exact. Tell me what is the answer. Look at see what is happening here, right? Tell me what is happening. Come on, why I'm not getting an answer? You look at this program, what is happening? Is this correct? Where my up should go, actually speaking, for a meaningful, my up should go here, right? Otherwise, every time it will be up should come here. Suppose my up is here. Okay, what exactly it is doing now? Every time it will read the data from the array, put it in AL register. It will overwrite. Yes or no? It will overwrite. Yes or no?
And to store the last value.
Exactly, you are right. Now, I will do the same thing here. Okay? I will do the same thing here. Same thing I will do here using LODS. But I will try to reduce certain instruction. I will do the same thing here. Okay, now what I will do, this will remain as it is, same thing, and count also going to be same thing, move CX 32H, this will be remain as it is, this is going to remain as it is. Right? Now what I will do, I will just try to make direction flag 0, okay? Then I will just write before this, I'll just write before this, repeat, see here, repeat LODS.SB, repeat space LODS.SB. Okay? See this code, okay? I will have move CX 32H, load effective address SI array, CLD, LODS.SB, repeat LODS.SB. This does the same thing what the upper one is doing. This particular code does the same thing what this is doing. Same thing. Now tell me, how much line I have actually saved here? How much line of code I have saved compared to this and this one? Increment SI is not required, yes or no? Okay? Decrement CX is not required, and jump on 0 is not required. What this LODS.SB does? LODS.SB internally increments the SI register by 1, okay, and moves the data from that memory pointed by SI register to AL register, right? And then checks whether the count is 0. If the count is not 0, it does repeats it. So now tell me, which are the statements we have saved? This one is not required, right? This one is not required here. This one is not required. This one is not required, right? Same, this operation is replaced by just 2 statements, CLD and repeat LODS.SB. These 2 does the same thing, but one is using string instruction, another one without using the string instruction. Only load AL, yeah. It won't use any other register. BL and all you cannot use in this string. Suppose if you want to use BL register, then you cannot use this code. Understood this? Okay. Now you have learned move SB, now load SB, store SB. This is called STOS. It's the reverse of load. It is the reverse of load S. What load S does? Tell me. It will read the value from memory to the AL register, right? That is the load SB. What is store SB? What is STOS? Store means it will copy the content of AL register or AX register to the memory. But it's very important. Earlier it was destination. It is supposed to be destination, right? Earlier it was data segment and SI register. But now it is Which register is the pointer? Pointer is AL, that is correct. Data is going from either AL, AX or AX. When it goes to the memory, see, STOS is actually the reverse of LODS. What LODS does? It will copy the data from the memory, okay, in the data segment pointed by SI register to the AL register, right? STOS is reverse. Reverse means what? It has to write the data from AL register to the memory. Now the memory is pointed by DI register, not SI register. Careful about it. Okay? Now while using STOS, STOS B or STOS W, you are copying the data from AL register or AX register to the memory. Now when it goes to the memory, which is the pointer register there? Pointer register is DI, but it is not in DS. It is storing in the another segment called as ES. Be careful about it. It's just a reverse of LODS. Okay? Now, let us write a program for this. Okay? Let us see how can we use this. Write an ALP to fill a set of 100 memory location starting at displacement DAT1, okay, with the value of F6H. Okay? Can you write this program without using string instruction? Without using string instruction. Can you write this? Without using string instruction. Can you write a program? What are you supposed to write? You're supposed to write F6 in 100 locations. You're supposed to write F6 in 100 locations. Okay? Now, can you write a program for this without using a string instruction? How do you write? Come on. Your DAT1 is, come on, tell me. Why you are not? DB 100 DUP question mark, yes or no? What is this? You all of you know about it. I need not explain this at this point of view, right? Okay, now come on, tell me. What is the program I should write without using string instruction? Move, come on. Or you can write first load effective address. I want to use, okay, I don't want to use string instruction. Okay, let your offset address of DAT1 to be in the DA register, okay? Yes or no? Yes. Okay, so how many times I have to put move CX? How many times? 100 times. What is the hexadecimal equivalent of 100? Or else you can just put 100, no problem. Don't put H there. Don't put H over there. Okay, then what else? What you should do? Come on. Move DI. What you should move to AL register first, tell me. Come on, tell me why you are not actually. First, I should put what I should put in the AL register. Whatever to be pushed to the memory, F6H. I should. Whatever it be. It is immediate addressing only. Fine. This is what you have to write. Then next, what you should do? Come on. Move. What you should do? Tell me. Move. DI, comma, AL. Then come on. Increment DI. Very good, Anna. Go ahead. Decrement CX. Jump on. No zero. Up. Now tell me where up should go now?
Move CX, comma.
Huh? Where up should go? I want to fill all these 100 locations with content of AL. Now, did I use any string instruction here? No. Now I can write a similar program using string instruction. Using string instruction. Okay, come on, tell me how to do this. What are the codes required now? This is required? Yes. This is required? Yes. This is required? Yes. This is required? No, why no? Something should be there in AL register, right? This is required. Okay, now see here, we will replace all these things. So what I should do next? CLD. Why CLD? Because I have to increment DI register automatically, right? Okay. Then what I should do? Repeat, store, SB. That's all. That's all. That's all. This is without using string, without string, and this one is with the string instruction. Have you understood now? Yes, that's what I'm using, right?
Because we are copying AL content to the
100 memory location. This will actually, this one statement will do the task of this entire 4 instruction.
So this array we are declaring the extra string. So how exactly do the extra?
How you do it? Tell me. Yes, see the statement, see you are doing move, okay, AX at the rate data, right? Now similarly you just do move, okay, DS comma AX, right? Same time you do move EX comma AX. This also along with AS, ES also you use the same segment address, so that it will, your data, whatever you are going to put in memory, you can use this segment address.
But then DS and ES will have the same.
No problem, don't worry. Why you're worried? Yes, that's a assembler job. Don't worry. One is extra segment, one is data segment, right?
The question is, there will be wastage of space, right? You're moving AX to DS, you're moving AX to ES. There will be wastage of.
It's not wastage. You're not using it, right? Not using it. Until you use, why you say it is waste? Move. DS comma AX is not required. Don't worry. If you are not using any data segment, if you're using data segment, you have to do. Understood this? Okay. Now, so how many string instruction we have seen now? Why is this? Sometimes it's okay. You can see the program. Can you tell me what is this statement? What is this statement? I told you about this. What is the replacement statement we have used? LEA, that's all. LEA, DI with just data 1 is same as move DI comma offset of data 1. It does the same thing. Okay, it does the same task. SCAS. What is this? This is very important. We have SCAS. What is this SCAS? Try to understand this. Okay, it is scanning the data, scanning the record. This is something used for searching something in the array, right? If you want to search something in the array, you have written a program in the lab, right? So what you do, every time you increment DI, increment SI and search, compare, yes or no? So instead of that, you can use one statement which will compare the data in the array and give the result. Okay, what it does? It compares AL register with a byte of data in the memory. It compares whatever data in the AL register with a byte of data in the memory. Okay. Similarly, you have, this is SCAS B, this is SCAS B. Similarly, you have SCAS W. What it does, it compares content of the AX register with the word in the data in the memory. Right? It compares the two locations in the memory. Similarly, this is for SCAS D. SCAS D. Okay? But now, what should be the pointer here? Pointer is actually, the memory pointer should be in the DA register, in which segment? Extra segment. This is very important. It should be in DI and should be in extra segment. Okay. Now, operands not affected, flag register definitely affected. Now, what are the three different versions you have? SCAS B, SCAS W, SCAS double word. Okay. You can use a prefix, repeat or not repeat. Repeat or not repeat. See, whenever you try to identify or search for a number in an array, moment you get your number, okay, you can come out of this. You can stop searching some other values. That's why you can use either repeat or repeat on equal, repeat on not equal. Okay, that means it will just stop scanning the value in the memory, okay, if the flag register 0 flag is set. You can do this. Repeat equal means, see, repeat equal, okay, SCAS B, suppose if you do, okay, so what it does, suppose I have a memory, okay, I will write a simple program here, see, suppose I have an array, okay, of, I think I have the slides in my next, yeah. Assume I have an array of some 8 bytes, okay. I have an array of 8 bytes, okay. I will write, I have an array of 8 bytes, okay. I want to check, okay, 25H in this. I want to check 25H, right. So what I will do, first I will just try to put move, okay, this, or I'll use effective address. I will use load effective address, okay, in DI, not in SI. If I want to use this SCAS in DI, okay, ARR. Now what I do, I will just move the pointer in CX register. You know, the pointer has to be put in the CX register. I'll just write 8H. The 8 bytes are there. Okay. Now I will just move, okay, the number to be searched, into the AL register, AL, 25H. Now what I will do, I will use CLD because I want to increment DI, because the next number to be checked has to be done by incrementing DI. Then I will use repeat, okay, repeat not equal, okay, repeat not equal SCAS B. Repeat not equal SCAS B. So what it will do, tell me? This will be repeated until content of AL register and content of the memory, which is pointed by DI, is not equal, right? When it will come out, tell me? When it will start, when this SCAS B will stop executing, when it finds something equal. When it finds something equal. Whenever it finds a number 25H in this array, suppose if 25H is here, okay, in the 7th byte position, okay, 25H is here in 7th position. So this compares the AL register 25H with content of this. That means your flag register has become 0, flag has become 0, right? Then definitely it has to stop doing it, right? It will come out, it will come to the next statement, right? Now, so can you tell me what parameter will give me the position of 25H in this?
Sorry?
DI will not give. DI will give only the effective address, right? But pointer may not be in the see, pointer doesn't mean that it is having a serial address 0012334. I've understood this. Okay. See, I say this is the 0th position, 1st position, 2nd position, 3rd position, 5th position. That is not the address coming to SI register. SI register is having the offset address. Right? Offset address may give, suppose your offset address is 1001. Okay? What is the offset address here? 1007, right? Can this be position? No. Which parameter will give the position? No. Tell me. There's one position you. No. In this program, tell me which parameter will give me the position of this 25H. Come on. AL is having this permanently. AL content will not be disturbed at all. Come on, CX na. See, when this stops executing, CX is decremented till this, incremented this till point, yes or no? CX is decremented, yes. CX is decremented, right? So it is decremented to which position? It decremented till some 2 or something, right? Right. You got the exact position of this. There are 2 ways you can find the position. One is from the CX count, okay? Now what is the CX count? You know total number is 8, right? 8 minus 2, you make it 7th, which position? 6th position. You can get the count, that is left to you, or else you can subtract this offset address to the first starting offset address, you can do that. Anyway, when it comes out using CX register content, okay, using CX register content, you can easily find out which position your 25H is there. You understood this, okay? Or else you can get it from SI, but if you want to get it from SI, you should know the current SI content and the starting SI content. Starting SI content, right? So subtracting that, it will give you the position of this number which is matched with the content of AL register. This is using string instruction. Can you write the same program without using string instruction? You can do it. But in that case, you have to use once again, you have to move the data to the one temporary register, use compare instruction, increment SI, decrement CX, all those things you have to use. But this is, you are not using those things and you are getting the program done. Okay? Fine, this is about SCAS. Okay. Now, next, the same program I told you, see, move AX comma data, move ES comma AX. What is this 0DH? I'm putting it into AL. Number to be searched. Okay. Now see, move AX, move CX. Now how many numbers are there? There are 80. Your array size is 80. CLD, see, repeat not equals SCAS B. Repeat not equals SCAS B. See, this instruction gives you the location of 0DH in this. Now, can you tell me what is this actually? No. This is a DOS interrupt. Okay. This is DOS interrupt for halt. So far you are using int3, right? Int3. Instead of int3, you can also use move AH, 4CH, interrupt 21H. Using DOS interrupt, you are trying to halt the operation of the microprocessor. That's all. Okay? You can use either int3 or you can use this. Both you can use. This one, this is the DOS interrupt, okay, which is used, we are using DOS interrupt, okay. This interrupt 21 is a DOS interrupt, it does so many things. it does the display. Suppose if you put 0, 2 here, it will do the display. If you put 1 H here, it will take the keyboard input. If you put 0, 9 here, it will display the string. Okay. Suppose if you put 4C and then call interrupt 21, it does the same operation as int 3. That's all. Halt. Yes, compulsory. AH putting 4C is compulsory. Like if you want to display character on the console, you have to put 0 to H compulsory, right? Then call interrupt 21H. And putting the ASCII value in DL is compulsory, right? Similar way, these two will. You can do. In that case, what you should use, tell me? SCAS W. Move? No. Yes, very good. In that case, don't use this. No, you can use this because this will be done once your AX task is done, right? See here, you can use. Why? Listen. By the time you come to this, you don't require AX register at all, right? You don't require content of AX register. Use it, no problem.
Overwrite.
No problem, because you're not using, your purpose is done, right? Once your purpose is done, you can reuse the registers. See, you have very limited number of registers in the 8086 processor, right? Once its task is done, okay, you don't require the value, reuse it for something else. Fine, okay? Okay, so compare yes, SCAS and compare S. Okay, it compares, see, SCAS what it does, it compares AL register with the memory, right? Don't you think you need to have something which compares memory to memory? Every location it will compare memory to memory. That's what compare yes is. That's what your compare yes is. It's comparing memory to memory. See here. What it compares? Listen carefully. You have two memory locations. See here. Two blocks of memory. I will write this as array 1, and I will write this as array 2. Okay? Array 2. I'll just take the attendance first because that time if it lapses, you cannot do anything. Okay, take your attendance.